Good day to all. Today in this video we are going to see about inductive effect. There are four effects that we have to know in organic chemistry. The former effect is the inductive effect. Before knowing about this effect, first we have to know the behavior of electrons. There are two important behavior of electrons. Once we are thorough with the behavior of the electrons, we can say that we are thorough with organic chemistry, or we are blessed with organic chemistry. The first behavior of electrons is that electrons will like to be, or love to be closer to the electronegative atom. That is the first behavior. Now let us see the example. Cl. I said the first behavior is electrons will always love to be closer to the electronegative atom. Here we can see that chlorine atom, which is more electronegative in nature. So what happens is it will pull the electrons towards itself, and therefore chlorine will possess slight negative charge. Whereas carbon, it will be capable of donating the electrons, and therefore it will possess slight positive charge. Here this delta means slight. Another example, if you take HF, fluorine is more electronegative in nature, and therefore it will possess slight negative, and hydrogen slight positive charge. If you take the bond between carbon and hydrogen, and here I am not considering the number of bonds. So oxygen being more electronegative, it will possess slight negative charge, and carbon will possess slight positive charge. From these examples, you can well define the inductive effect. So inductive effect is an effect in which one atom pulls the electrons towards itself, and the other atom donates the electrons. Now we will see the various other definitions of inductive effect. The effect of the sigma electron displacement towards the more electronegative atom, by which one end becomes positively charged and the other end negatively charged, is known as inductive effect, or the displacement of an electron pair along the carbon chain due to the presence of an electron withdrawing or electron releasing group in the carbon chain is called as inductive effect. It is actually, an inductive effect is a permanent effect, and it can also be defined as, inductive effect is defined as the permanent displacement of shared electron pair in carbon chain towards more electronegative atom or group. The inductive effect refers to the polarity produced in a molecule as a result of higher electronegativity of one atom compared to the other. Or inductive effect refers to the phenomenon wherein a permanent dipole arises as in a given molecule due to the unequal sharing of the bonding electrons in the molecule. Now we are going to see the significances of inductive effect. Already I have said that inductive effect is a permanent effect. It arises due to the electronegativity difference of two atoms forming a sigma bond. It is transmitted through the sigma bonds. No pi bonds are involved. The magnitude of inductive effect decreases while moving away from the groups causing it. It is a permanent effect, and it may create permanent dipole in the molecule. In general, the inductive effect is relatively weak, and it is overshadowed by other electronic effects like resonance effect and hyperconjugation. It influences the chemical and physical properties of compounds. Now we will see the types of inductive effect. Inductive effect is classified into two types. One is plus I effect, or positive inductive effect, and minus I effect, or negative inductive effect. We will take the same example, carbon, chlorine. Here I said chlorine is more electronegative in nature, and therefore it will possess slight negative charge. Carbon possess slight positive charge. So chlorine atom pulls the electron towards itself. Therefore it has minus I effect. Carbon atom donates the electron. Therefore it possesses plus I effect. Okay. So when an atom is capable of pulling the electrons towards itself, it possesses slight negative charge, and therefore we can say that it has minus I inductive effect or negative inductive effect. When an atom is capable of donating electrons, it becomes positive inductive effect. Now we can take another example, CH3, Cl, F. Here if you see, chlorine is electronegative in nature, and therefore it will donate CH3, CH3, Cl, F. Chlorine being more electronegative in nature, it shows minus I effect. Fluorine also being electronegative in nature, minus I effect. CH3, which is donating electrons, will show plus I effect. Now we have to see the types. So I said there are two types, that is negative inductive effect and positive inductive effect. Negative inductive effect, the electrons withdrawing nature of the groups or atom is called as negative inductive effect. It is indicated by minus I, and this is the decreasing order of the minus I effect. Now we will see the positive inductive effect. It refers to the electron increasing nature of the group of atoms, and it is denoted as plus I effect, and this is the decreasing order of the plus effect. Now we are going to see the applications of inductive effect. Before seeing the applications, I'll just give you an example. We will see an example, that is we will see two molecules, CH3, CH2, CH, Cl, CH2, OH, and CH3, CH, Cl, CH2, CH2, OH. In both the cases, we see that there are 4 carbon atoms, but the substitution position has changed. In the first case, the substitution is in the second carbon atom, and in the second case, it is in the third carbon atom. Okay, here we can see that both show, since both have electronegative atom, that is chlorine, it shows minus I effect. In both the cases, minus I effect is there. So which has more minus I effect is that? In this case, the pulling effect will be less when compared to this case, structure 2. Because as the distance goes on, we can see that the pulling effect will be greater, and therefore the minus I effect will be greater in the case of structure 1 rather than the structure 2. Okay. So now we are going to see the applications. There are 3 main applications that we are going to study, that is the stability of carbocations, basic strength of amines, and the acidic strength of carboxylic acid. We will see one by one. That is the stability of carbocations. Just see this example, that is CH tertiary, secondary, primary, and methyl. The tertiary carbocation containing 3 alkyl groups is more stable than the secondary carbocation with 2 alkyl groups, and which is in turn more stable than the primary carbocation. Methyl carbocation is the least when it is compared to the other. So the stability of carbocations increases when the plus I groups like alkyl groups are present adjacent to the positively charged carbons. The plus I groups reduce the positive charge on the carbon by donating negative charge density through the positive inductive effect. This results in the greater stability of carbocations, whereas the minus I group destabilizes the carbocations as they increase the positive charge by withdrawing the electron density. That is what we saw in this case. Now we are going to see the second application. The second application is the basic strengths of amines. Here you can see the example, that is CH3NH2 greater than NH3, C6H5NH2. So this is the order of basic strength of alkyl and aryl amines with respect to the ammonia group. That is, the electron donating groups like aryl or alkyl groups increase the basic strength of amines, whereas the electron withdrawing groups like aryl groups decrease the basic strength. Therefore, the alkyl amines are stronger Lewis bases than ammonia, whereas the aryl amines are weaker than the ammonia. The last application is the acidic strength of carboxylic acids and phenols. So a protonic acid is always in equilibrium with its conjugate base, that is formed by the loss of proton. Any factor that stabilizes the negatively charged conjugate base favors greater ionization of acid, that is increases the acidic strength. The electron withdrawing groups showing negative inductive effect reduces the negative charge or the conjugate base by pulling the electron density, and thus by destabilizing it. Hence the acidic strength increases when minus I groups are present. When there is plus I groups present, they decrease the acidic strength as they destabilize the conjugate base by acid. Now we are going to see an example. This is the electron withdrawing fluorine atoms shown here. The acidic strength increases with increasing in the number of electron withdrawing fluorine atoms. Another example we are going to see in the formic acid. That is, in formic acid is stronger than the acetic acid because there is CH3 group which destabilizes the carboxylate ions. Another very good example is there for para-nitrophenol, phenol and paraclusol. Here we can see that the acidic strength is increasing in this order. The para-nitrophenol is stronger acid than the phenol since the NO2 group is a minus I group which withdraws the electron density, whereas in the paraclusol is a weaker than that of the phenol since CH3 group shows positive inductive effect. Okay, so in this video we have seen the definition of inductive effect, the classification of inductive effect and the applications of inductive effect. Two things that you have to remember is the behavior of the electrons. The first behavior is that electrons always like to be closer to the electronegative atom, and the second behavior of electrons is that electrons are negatively charged and they always prefer to stay close to the positively charged. For this I can give an example. Now we will see this example, that is CH3, CH2, Cl. Now we will see the behavior of electrons here. That is, chlorine being more electronegative, it possesses slight negative charge. We can see minus I effect here. This carbon donates, so it possesses slight positive charge. This is our first behavior, that is, electrons always like to be closer to the electronegative atom. The second behavior of electrons is that electrons are negatively charged and they love to come close to the positively charged atom. So here we have positive charge, electrons being negative, so it will come closer to the positive charge. Therefore, this carbon atom possesses slight positive charge. So by this, I think you will be clear with inductive effect.